it would be useful for us, first of all, to classify all these graphs together as either quadratics. One would be like this, and we would call that concave up. And I remember it being up because the U here, the U is actually looks like the graph itself, like that parabola. And I can also do the other one would be concave down. So that's one lot. Now if I go and have a look at cubics, it's another group of graphs. Cubics have a look that look like this. And there is also one which is symmetrical. I might draw it this way. What they have in common is that they've got a maxima and a minima. So I can do a maxima here and a minimum point, and on the other one it would be a maximum and a minimum. So quadratics only have one maxima or minima, whereas the cubics will have two. So there is another set of cubics that will look a little bit differently, and these cubics will look like this. And this is the common one, which is usually y is equal to x cubed. Now you might ask, well, where is the maxima and the minima? In fact, the maxima and the minima are together as double roots. So I will put them here, there, and you'll find that that is what we will call now stationary inflection. The same thing goes for the mirror image of this, and once again right here is the stationary point of inflection. So I'll just put SI for stationary inflection. So there are 4 variations of the cubics that we need to watch out. Finally, I want to also go through another group of them, and these are the quartics. And the quartics will have 3 horizontal gradients on that. And in this particular case, it's going to be 2 maxima and 1 minima. And the same thing goes for its mirror image. I could draw it this way. Now this time I've got 2 minimas and 1 maxima. And there are 4 other variations that I can draw from this, with 1 maxima and a stationary point. Okay, so the maxima will be right at the top over here, and to the right, that is actually a stationary point of inflection. So just drawn it over here. Now I've copied this same quartic and turned it upside down so that we can see that it also can have minima this time around here, and also to the left over here is going to be a stationary point of inflection. These last 2 graphs can be now reflected in the y-axis. If I was to draw our y-axis, and then I can redraw them again, so to speak, to the right over there, but I'm not going to bother about this because it's not worth it. Just know that there are 2 other versions of this. Okay, another thing noting about these is that between the maxima and the minima, you will find another point of inflection, but this time it's non-stationary. So in the cubic, in the very first one, there will be one right here on that dot, where I'll find a tangent that is a point of inflection. There is another one in here between this minima and maxima, and none in the because in the third and the fourth we've got stationary inflection. So let's go into the quartics. There's a point of inflection, and here is another point of inflection, and so on, and one here and one here. Now, is there a point of inflection at this point? Yes, there is. In this graph, there's just one here, and there is another one here. What these mean will become apparent when we start graphing these. Okay, so we can start graphing this, but you have to know that we always start, when we're doing if we start with a quartic, okay, a quartic graph will, when we do the derivative of it, will become a cubic, and a cubic will become a quadratic, and a quadratic will become a linear, and a linear becomes a constant. Okay, so now a derivative usually finds me the slope of that particular function. So what I'm going to be most interested is in the horizontal tangents. And the horizontal tangents are going to be at the maxima, at the minima, and here at the maxima. So I'll draw a dotted line onto my next axis to show me where these points would be, because on that next one I'm going to do the second derivative. These are my minimas and my maximas. So firstly, I establish where the maximas and minimas are, because these will be 0 on our f dash graph. Secondly, highlight the parts of fx where the slope is positive or negative. So I'll find that this part of the graph gives me a positive slope, and there is another part, this one over here, also shows a positive slope, and that's it. On the other hand, this part shows me a negative slope, and this part shows me that this is also a negative slope. The positive slopes on my derivative must be above the x-axis. So if I was to, that's my third point. So let's look at it really closely. I'll bring this up right close, and let's have a look at that first positive slope. Right at the beginning, we have quite a large, big positive slope. This slope begins to get smaller in terms of its size, and smaller, but it's still positive. It's still positive, but in the size of it gets smaller, and it's smaller until it reaches a 0. The slope here is 0. Let's just go on with this bit and have a look at what's happening in the next part of the section. Now our slope begins to go negative. It's not a very steep slope, but it gets steeper and steeper and steeper and steeper and still steeper until it gets to a point where I think where it probably is the steepest, and then it begins to get less steeper and less steeper and less steeper and less steeper until we come up to the very bottom where once again the slope becomes zero. What's actually happened at that particular point where of its great negative steepness? This is going to be associated with a non-stationary inflection. And I will write this here as a fourth section. The negative slope will be shown below the x-axis. So coming back to my graph over here, we need to now go below. But remember that it gets up to a stationary point and then it begins to go, the steepness decreases again. So what we'll do is we'll just go down and decrease the steepness, go up. So as you can see, this point here will refer to the non-stationary inflection. Now we'll do the next positive line, and as you notice, let's just have a really close, once again a close look. We start off very, very small steepness in the in the positive direction, and this increases until once again it gets to a maximum value over here, which we'll call a non-stationary inflection. And this positive sign then begins to decrease because the steepness of it gets smaller until we get to zero, and then we start on the negative values again, and the negative values start increasing in steepness. So to draw this next part where we want to be showing we'll go up until we get to this top of that and come back again to zero. So this is once more our non-stationary inflection. Okay. What happens now is that our values for the slope are negative, so they must be below the axis, and they will continue on this way. Now, let me just bring everything back together again here, and you can see what's happened over here. So this is what our function, our derivative function f dash looks like. Okay, we've gone from fx to f dash x. We started with a quartic, we went to a cubic, and we can now continue this. And after a cubic, you know what comes next? Quadratic. Now those non-stationary inflections now become a minima, and this one becomes a maxima. So we do the same thing. We draw a line down across, and these become our zeros. The second step I said was to highlight the parts of the fx where the slope is positive and negative. So our positive slope is now in the center here, coming down like this, and our negative slope is on the two sides. So I said before that the positive slope will be shown above the x-axis, so we can now show the slope above the x-axis. Well, let's start with that negative slope. It decreases from a low negative to a 0. And at this point, it goes into the positive part of the axis, right up where we would get to the maximum of the stationary point, come back again, and go down again. And we've got what we expected. We had a cubic here, and now we have a quadratic, a parabola. And what would you expect a quadratic to become once we do the derivative? Well, we once again mark the maxima and drop it down all the way down to the graph, mark that as 0. And now we look at the slopes. We have two types of, we've got a positive side and a negative side. So go with the positive side is on this side, and the negative is on that side. That's the slope. The positive side will go on the above the x-axis, and the negative will go below. So what we end up getting is we get what we would expect, a linear function going down. Okay, so these are the stages in which we start finding graphing from quartic to cubic to quadratic up to linear.